All right, let's get started here. So it says r equals 5 sine 2 theta. Going in, hoping that everybody was expecting double this number of petals, so 4 petals of length 5, and then to find the tip of each petal. To get double the number of petals, we just show in our work that we know that we get different ones from positive and negative r values. So since the maximum value is 5, we'll just go ahead and put plus or minus 5 in for r, and then solve for theta. So let's divide both sides by 5. And then at this point, we're unit circle ready, so I'll just go ahead and draw a little unit circle. I'll mark the places where the sign is either plus or minus 1. And then we're looking for 2 theta to basically equal pi over 2 plus pi n. To solve for theta, we're going to divide both sides by 2, and we get theta is equal to pi over 4 plus pi over 2 times n for all n from the set of the integers. Okay, so what does this tell us? So you could just start plugging in n values starting at 0, and then just generate your angles where you'd have tips of petals. So like if n was 0, for example, theta would be pi over 4. So at pi over 4, 1, 2, 3, 4, 5, I would have a tip of a petal there. Let's see, if n was 1, I could just have pi over 4 plus 2 pi over 4, which would be 3 pi over 4. So at 3 pi over 4, I'd have a tip of a petal. And then you can also think of this as just starting at pi over 4 and adding a fourth of the circle, multiples of the fourth of a circle. So you could also count the spokes, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then fill it in, and what I'm looking for when you fill it in is that you have 4 petals, and they don't like overlap with each other in here toward the center at all, but they do go through the pole between, you know, from one petal to the next. They're supposed to be perfectly symmetric, but mine never are. There we go. And that's really what I was looking for. So points, notice the direction said show the algebraic analysis for finding the location of the tip of each petal for each rose curve. So I'm looking for work like this to give you, you know, part of the credit. So, so first thing, it's worth 2 points to have set your expression equal to plus or minus 5. And equivalent to this would be if you don't have this 5 here, and you have plus or minus 1 here, so like if you skipped to this step, then that would count. So plus 2 for that. Let's see, the next thing I'm looking for is for you to have 2 theta set equal to pi over 2 plus pi n. Let's see, point for that. When you solved for theta, pi over 4 in your answer is worth 1 point, and then plus pi over 2n is worth another point. And then this really should be here. I don't know if I'll have enough points to like give it any necessary credit for this, but I do hope that you have a habit of writing that. Later on, you'll be glad you have that habit of kind of thinking that out just a little bit. Let's see, so that's 5 points, yeah, 5 points so far, so 5 more points for this. So let's see, we'll give you 1 point for just having a rose curve with 4 petals, even if you screwed up the other details. And then, let's see, oh, of length 5, that is. Okay, so 1 point for having that. And then the other 4 points are for having these 4 points of accuracy. So, you know, 1 at, you know, 5 pi over 4, 1 at 5, 3 pi over 4, 1 at 5, 5 pi over 4, 1 at 5, 7 pi over 4. There we go, and that's the 10 points for that one. Okay. Very similar, part B. There are 2 ways to do it. you could set r equal to +4, which I prefer, and then solve for theta, knowing when you're done, your angles are places where you should go toward those numbers 4, because you asked for when r would be +4. Now, if you set r equal to -4, you could get the same picture that I'm going to get, but you do it by taking the angles you get and going away from them 4, because you asked for r to be -4. So it's really just a matter of paying attention to what you asked for. So basically, if you get kind of a mirror image of what I'm getting, then it's likely that you asked maybe for r to be -4, but then you treated it like you asked for r to be +4. I hope that makes sense. Okay, so since you have an odd number here, you'll get exactly 3 petals. And so I'll set r equal to 4. And then just solve for theta. So dividing by -4 would give me a -1 over here. This is unit circle ready, so I'm just going to look for places where my cosine would have been -1. And then, so that would give me 3 theta would equal pi, and then I'd have to go all the way back around. And then divide both sides by 3, and you'd get theta would equal pi over 3 plus 2 pi over 3n for all n from the set of the integers. There we go. Okay. Now turning this into a graph, you could just plug in different n values starting at 0 and generating angles. So like if I let n be 0, I'd get pi over 3. And I asked for when r would be 4, so I should go toward it 1, 2, 3, 4 because of the equation that I set up and solved. And then if you were to plug 1 in for n, then you'd get pi over 3 plus 2 pi over 3, which would be 3 pi over 3 or pi. So you're going to go toward that 1, 2, 3, 4. And then if you let n be 2, you'd end up with 5 pi over 3. So toward 5 pi over 3, that's here, 4. There we go. And then fill it in. Okay, so let's see, points very similar to the way we scored the last one. 2 points for setting up this equation. Again, you could either have a 4 or a -4, but it would be incorrect to have like a plus or minus like we did over here. Okay, so 2 points for having the problem set up correctly. If you skip this step and went straight to the next step, that would also suffice for those 2 points. Okay. 1 point for having 3 theta set equal to pi plus 2 pi n in your work along the way. 1 point for setting theta equal to having kind of this initial value here of pi over 3. And then 1 point for showing that you're adding basically a third of the circle, which should make so much sense because we were expecting 3 petals. Anyway, so this should be here. Pat yourself on the back if you have it. Add it in if you didn't. It's worthwhile to kind of keep trying to remember to add things like that. Anyway, so that's 5 points so far. And then the last 4 points are 1 point for having a rose curve with 3 petals of length 4. Even if you have them in the wrong place. 1 point for having that. And then the last 3 points are for having the tips of the petals in the perfectly right places. So 1 for each. There we go, and that adds up to 9.